I'm asking you.
Voltmeter.
Voltmeter. What characteristics of voltmeter are required?
Parallel to the conductor and high resistance.
High resistance of voltmeter, and it should be connected in parallel. Why high resistance is required for voltmeter?
Because then only you can find the difference in potential. You can
What
find the
what
potential difference.
How is it playing a role in finding potential? When the resistance is high, how does it help you in finding the potential?
Like the end of the this one will be different from the other.
Sorry. When the resistance is high, then what happens is that then and we are connected in parallel. So the current does not passes through that circuit because of high resistance, and the reading of the voltmeter is accurate. Okay. Hmm. Now, if I want to measure the electric current in a circuit, which appliance or device will I use?
Electric current ammeter.
Ammeter. What are the characteristics of an ammeter?
What?
Characteristics of ammeter.
Ammeter characteristics. It should be placed in series and it should have low resistance.
Low resistance. Why it should have low resistance?
Because then only there won't be difference in the electric current.
Difference in electric current? Is that even a term?
Like there won't be difference in the current flowing to the circuit.
I'm not satisfied with the answer. What will be the effect of low resistance? Tell me in light of that. Highlight the word low resistance.
Like due to low resistance, the current flowing to the circuit will be constant.
The current will not be affected by low resistance, and if the current resistance is high, so what will happen? It will block the flow of current. High resistance, if we use it in ammeter, it will block the flow of current. That is why we use ammeter of low resistance in series and voltmeter of high resistance in parallel. Okay. Okay. 1 milliampere is equals to how many ampere?
1 milliamp is equal to 10 to the power minus 3 and 4.
Sorry,
10 to the power minus 3.
ampere. Okay. And 1 microampere is equals to
10 to the power minus 6.
hmm. Okay. Okay. I think we wrote some points last lecture. We were not able to see them, right? Tell me, what is the direction of flow of electric charges in a conductor?
From negative to positive.
Negative terminal to positive terminal. Okay. And what is the flow of current? Direction of flow of current?
Positive terminal to negative terminal.
Positive to negative. Okay, very good. The conventional
Sir,
direction of electric current.
1 second, can I on the fan?
Yeah, sure.
Okay.
So as we saw, that conventional direction of electric current is from positive terminal to negative terminal through the outer circuit, right? Now let's do some question. Okay, did we discuss the formula of current? Yeah, we did. Did we? Yeah, we did. I is equals to Q by T.
Yeah,
We did discuss, right?
yeah, we did discuss.
Where Q is
That Q is
charge, T is
time,
time, and I is
current,
current. What is the SI unit of current?
ampere,
Hmm?
ampere,
Ampere. Okay. SI unit of charge?
SI unit of charge is coulomb,
Coulomb. And time? Second.
seconds.
So we can say that 1 ampere is that. See, 1 charge of coulomb flows through any cross section of a conductor. 1 coulomb of charge is flowing through a conductor of through a conductor in 1 second. Then the electric current flowing to be is said to be 1 ampere. That means a conductor who in which when the charge of 1 coulomb is flowing through a conductor in 1 second, then we say 1 ampere current has passed through that conductor. Okay, let's do some question. When you're done writing, tell me.
7.
Hmm. So what? Tell me what all is given in question.
The I is equal to 0.25 ampere.
Hmm. So that means current is given to us. Current is equals to 0.25 ampere. Okay. What else is given? Time is given. 20 minutes.
1200 seconds.
That is equals to,
1200 seconds.
repeat. I'm not able to get what you said.
1200 seconds.
Yeah, 1200 seconds. Very good. So now can you find the charge that flows
Yeah.
through it?
Three hundred columns.
300
Column.
coulomb. If I make a B part of this question and ask you that in this 20 minutes, how many charges pass through the conductor or pass through the circuit? Can you tell?
Q is equal to NE.
Yeah.
That means 300 is equal to N into 1.6 into 10 to the power minus 19.
Hmm.
So if we divide it, it will become 300. 1.6 into 10 to the power 16 is 1875 to 10 to the power 19.
Hmm. 187.5 10 to the power 19 charges pass through in 100 1200 seconds or 20 minutes. What all is given?
Potential difference is 10 watt
Yes.
and current is 2 ampere
Hmm. And time.
and time is 60 seconds.
Hmm. So, what do you have to find out?
You
Energy.
have to find out energy.
This is the work done. You have to find out. How will you do? Tell me, which formula have you read in which work is involved? W. W comes in which
V is,
formula?
V is equal to W by Q.
V is equal to W by Q. You want to find W. You have V? Yes, you have V. Do you have Q? No, you don't have Q. Can you find Q?
Yes.
Yeah, then find.
1200 Joule.
120.
1200.
Okay. So what charge did you find out? What was the value of charge you find out?
I is equal to Q by T 120 column.
120 coulomb. Now you applied V equals W by Q. So the work done or the energy transferred was found out to be 1200 joule.
Uh,
Hmm. Okay, good. Give me one more question. Hmm. Okay, do this question. Start writing question.
Yeah.
Hmm.
So 10 to the power 20.
Hmm. Very good. How did you find it?
By finding I is equal to Q by T, we saw
Hmm.
Q is equal to 16 coulomb. By
Hmm.
equation Q is equal to NE, we
Hmm.
saw before I found 10 by 20.
Okay. Good. I think your numerical part is almost nicely done. Now let's see some equations on current and voltage relation and the graphs based on it. Okay. Hmm. So the current flowing through a conductor. Now we talk about potential and current. How potential and current is related to each other, right? So we know that the potential is directly proportional to current, right? And through which law states that the potential is directly proportional to current? If you have any idea, I'm asking you.
What?
Potential is directly proportional to current. Have you read of any formula which states that when what
V
kind
is
of
equal
law?
to IR.
Hmm?
V is equal to IR.
What is that formula called?
So
Ohm's law. So Ohm's law states that V is equals to IR. So which means that V is directly proportional to I. And what is the meaning of this statement? Proportional means when you increase voltage, so current in a circuit will also increase, right?
mm,
Now, right one statement. The current flowing through a conductor, the current flowing through a conductor is directly proportional to the potential difference, directly proportional to the potential difference across its ends, across its ends at a constant temperature. Written.
Yeah.
Hmm.
Okay, sir.
Hmm. Now write this. V is directly proportional to I, which means V is equals to IR. Written. In this
Yes.
you write, what is V? V is the potential difference. V is the potential difference. I is the electric current, and R is called resistance. R is constant, is a constant. You know that R, this resistance is a constant. Hmm. So from V is equals to IR, we can say that R is equals to V by I, right? Now you can find resistance also. Hmm. Okay, after doing this, I'll give you a question. Okay. So potential difference, you must be knowing that V is equals to IR. V direct proportional to I means if you increase the potential, which means that if you want, you can write this statement also that V is direct proportional to I means when you increase the potential, the electric current also increases right here. Like make an arrow and write here. When you increase the potential, electric current also increases.
We increase the
When you increase the potential difference, the current in the circuit also increases. Write this. Write this. Done. Written. Written.
person.
Okay. So what does it say? The ratio of potential difference applied between the ends of a conductor and the current flowing through is also called resistance. Now, if someone asks you how to define resistance, so you can simply from V is equals to IR, you can do R is equals to V by I. You can say R is equals to V by I, which means that resistance in a conductor, what is simply the ratio of what? The potential difference between the ends of a conductor and the current flowing in that conductor. is called resistance. Simple? Yes, Umar?
Yeah.
Hmm. Okay.
Yes, sir.
Right. The current is directly proportional to the potential difference. Star point number one.
So wait.
Hmm? The current is directly potential difference. The current is inversely proportional to the resistance. Hmm. Okay.
Yeah. Already.
Hmm. Now you tell me, if I if I double the current in a circuit, first you write.
Yes, sir. Done.
Hmm. What is the first star point? Repeat.
Is directly proportional to potential difference.
Speak louder.
The current sh- the current is directly proportional to potential difference.
Means if I
The
increase
current
current,
is
which means if I increase current, potential difference will increase. Or if I increase potential
uh,
difference, current will increase. Which means if I increase any one, the other one will increase. Now tell me, if I make the potential difference, if I double the potential difference, now what will be the value of new current?
what
If
if I
I double
double
the
the
potential difference, the new current will be
double
double. And if I if I double the current, what will be the change on the resistance?
it will be half.
Becomes half. And if I um, double the potential difference, what will be the change on the resistance?
Huh?
If I double the potential difference, what will be the change on the resistance?
The potential difference. The resistance is constant, sir.
Resistance is constant. Okay, good. If I double the resistance now, what will be the effect on the current?
It will be half.
Yeah, very good. Okay, so write this also. These points also we write. Point number one, right? If the potential difference across the ends of a conductor is doubled, so the current flowing through it is also doubled.
Huh? What?
written.
Yeah.
Okay. Now we'll see the graphs of Ohm. Oh, did we write Ohm's law here? Oh, please write
uh,
Ohm's law.
you don't.
This is Ohm's law. Please write that. Okay. Now, if we see graphs of this potential and current, so you know that potential is directly proportional to current, right? So the graph, when both are directly proportional to each other, the graph is a straight line. So if we make the graph, let's suppose here I'm making the graph of potential versus current. Or you can say I want to reverse the graph because if V is directly proportional to I, which means I is also directly proportional to V, right? We can make the graph of V versus I or I versus V. Now, which means that when put I versus I proportional to V or V proportional to I means that when you increase V, I increases. When you increase I, V increases. So the graph in both the cases will be straight line, right? It is a straight line graph. V versus I graph or I versus V graph is a straight line. And this line that comes in the graph is called the slope. This is the slope, right? First we make this, then we'll see the later condition. Done?
Yeah.
Hmm. Tell me when we're done. Okay. So since both are proportional to each other, their graph is a straight line, but the slope will be different. Do you know what is slope of a graph? What
It's
is the
like a
meaning of slope?
resistance.
Hmm?
It's the resistance.
No, no, no. I'm asking what is slope in a graph? So
Like the
slope
line.
means the ratio of y-axis upon x-axis. That is the slope, right? Now in this graph, so you know on the y-axis we have v, so this means it's equals to v upon, and on the x-axis we have I. So v upon I, which is equals to r. So the slope of, so now we can write, and what was this graph? This was vi graph. First we read the v, then we read the I. This was vi graph. So you say the slope of vi graph is, what is the slope of vi graph? The slope of vi graph gives r, which is resistance, right? Now let's see here. Here also slope means y-axis upon x-axis gives us the slope. Now here, what is on the y-axis? I. This means it is I upon v, right? And now
Yeah.
I upon v is not equals to r, it's equals to 1 upon r. Because v upon I is equals to r. Now if you reciprocate it, this resistance also becomes reciprocate. So the slope of IV graph is 1 by r. Okay. The slope of IV graph gives 1 by r. Reciprocal of resistance. Understood? Understood?
Yes, sir.
Hmm. Because this here the formula got inverted. That is why the resistance also got inverted. Write it.
Okay, so now,
Hmm. Write this in this. Write in VI graph. Steeper the slope, higher the value of R. Higher will be the value of R. And here in IV graph, steeper the slope, lower will be the value of R. Hmm. Do you understand this point?
yeah,
Because VI graph gives resistance, the more steeper graph will, the higher will be the value of R, right? Because the higher the steeper it is, the higher the value R because it gives R. But in case of IV graph, it does not give R, it gives 1 upon R. So that is why the more steeper, the lower will be the value of R. Written? Hmm?
yeah.
Hmm. Now put the heading resistance. In resistance, right? It is the property of a conductor due to which it is a property of the conductor due to which it opposes the flow of current through it. It opposes the flow of current through it is called resistance. Next point, right? The resistance of a conductor, the resistance of a conductor depends on the length. The resistance of a conductor depends on the length, comma thickness. Written. The resistance of a conductor
Right, right.
depends on the length, comma thickness, comma nature of material, length, comma thickness, comma nature of material, and temperature of the conductor. The resistance of a conductor depends upon length, thickness, nature, and material of a conductor. So we see that resistance is a constant, and this constant depends upon what factors? It depends on the length. If the length is more, will the resistance be more or less? I'm asking you.
Yeah,
If the length is more, we have written, na? The resistance of a conductor depends on length, thickness, nature. So if
yeah.
the length is more, will the resistance be more or less? More.
Yeah,
Hmm. If the thickness is more, will the resistance be less or more?
will be less.
Will be less. How come? Which formula you are saying to it?
Uh, R is equal to rho R by A.
R is equals to rho L over A. Okay. If the temperature is more, then the resistance will also be more, right? Hmm. Now, right. Next
Yeah,
point. The SI unit of resistance is ohm. Ohm. SI unit of resistance is ohm. Next point. 1 ohm is the resistance of a conductor. 1 ohm is the resistance of a conductor such that 1 ohm is the resistance of a conductor when a potential difference such that when a potential difference when a potential difference of 1 volt is applied, potential difference of 1 volt is applied to its ends. The potential difference of 1 volt is applied to its ends, comma, a current of 1 ampere flows through it. A current of 1 ampere flows through it. Written. So
Rasa kami sa
Hello, hello.
So
What happened?
connection of
Yeah. So what I was saying, what have we written about resistance? What is the SI unit of resistance?
ohm.
Ohm. And what is resistance? So first we have seen one theoretical definition, one definition through formula. So theoretical definition of ohms would be it is the property of a conductor due to which it opposes the flow of current through it is called resistance. Right? One which you have just written. The conductor, the property of a conductor due to which it opposes the flow of current is called resistance. And the other definition by formula, which we just saw was where
is equal to IR.
define it.
Like when the current is small, the potential difference
No, we saw definition of that resistance is the ratio of potential difference across the ends of a conductor, right? To the current flowing through it. See, we have written it. Found. Found or not? No. No, man. No, man. No. Hello.
balance and
There was a lot of glitch today in your class. Maybe in next class you can fix it, okay? Umair, okay?
yes, sir.
Okay, then revise whatever we have Then okay. Okay, bye.